welcome to CppBayArea. Like Max was saying, this is a reprise of a talk I've given before. And he said this is about how you would like build a UI library in C++. That's not what this talk is about. Just kidding. Yeah. What this actually is I've been using a C++ library called WX widgets for a long time. And what I found, it's a great library. But in the course of refactoring and learning how to use this library, I stumbled upon a series of techniques to build code that was more declarative. And I actually found that that was a better programming style. And so I wanted to come here today to talk about that, sort of the techniques that I use for building declarative a declarative UI. And I actually think a lot of these techniques you can start using in your code when you're programming, when you're thinking about what you're trying to do. So I'm hoping that you don't take away from this talk about what this UI library is. Take away the lessons about thinking declaratively instead of imperatively, and how you could bring that into your code or some of these techniques. So I'm going to be using WX widgets. And if you haven't heard of WX widget, that's fine. It's a very sort of niche C++ library. It is a UI framework similar to Qt, or if you've heard of Juice. Those are other C++ libraries that are UI frameworks. And I'm going to say I'm not a definitive expert on WX widgets. I use it for a little toy program I help with. And so I've used it a lot, but I don't want to claim that I'm an expert. And I'm not an expert on UI frameworks. There's a lot of expertise on that. For people who've worked with Cocoa, UIKit, whatever Microsoft has, Electron, there's all sorts of various frameworks about UIs. And one of the things that I found when building up UIs or when you're programming is the type of program you write is greatly influenced by the framework you use. And what I mean by that is if you try to go against the UI framework, you find yourself being like you're fighting it. But if you follow the paradigms and the patterns of the UI framework, generally it works. I'll note like some of the usual things we ascribe to in C++ about lifetime management will be kind of weird. You're like, wow, there's just naked news all over the place and all of these allocations. I'm not sure who's handling this, but generally the UI framework with their paradigms, they have reasons for writing their code in a particular way. Why don't we start off to put a little bit on, I'm going to actually do a live demo on making a bit of a little tiny application with WX widgets to sort of give everybody an idea of what the general way you do it is. So I have this actually a project. This is set up here on GitHub under my RMPL77 account. So if you wanted to play along, I actually have this set up for these slides. So you can go there, download this, start trying it out. I tried to note the branches for the slides that they go to. So if you're doing this at home, coming here so we take a look. I am going to start ourselves off on example 1. And at the very beginning, I just have a simple directory. I have 3 files in here. I got my CMake file, got my Hello World application. Actually, and build is just the directory because I've already opened this before. And so if I come over to this, my CMake file, pretty straightforward, standard CMake setup. I'm using C++ 20. I probably could move that to 23, but I didn't. I'm using find package. I'm sure there's some opinions about the way I should use a package manager. We'll get into that. That's a different talk. But I'm using find package. WX widgets has it integrated into CMake. If you do this, it'll just download from Git the latest version it needs. It'll find it for you. And then I'm adding the executable I want. It's just going to be this hello world file. Link up together, and that's all I need. Thank you for the helpful hint. And what does my hello world look like? Pretty straightforward. This is like more or less copy and paste from their getting started guide. I can kind of see the basic, oh, I have an app and it's inheriting from the WX app. Oh, I've got a frame. Okay, and then on a init, it'll make a frame. Cool. Okay, so if I just build and run, I should end up with some app that just got launched here. Ah, yeah. So now,
Wow.
wow. Okay, great. Whoa, okay. Okay, hold on. Let me. So if I let's do something a little bit more interesting than that. Let's. I already had this pre-baked, and so if I look in here, I can actually probably make that a little smaller here. So I'm going to add in my frame. I'm going to have. This is their sort of paradigm of you can create function calls that are private, that they're members that are going to get called by the UI when certain events are done. There's an event table and enumerations like, oh, hey, whenever you're told to exit, call the onExit function. And so you end up with this, oh, I got a menu system, and you can kind of see, okay, I'm going to have a little ID, separator, exit, about, the usual help menu, the sort of things that you would expect, and a little message box. So if we build and run this, quit this one first, allow this one to run. So now I've got now, ooh, nice little, I've got my menus are showing up there. I have a little status bar at the bottom, really starting to come together as my amazing application. And then if I go further and I start laying out controllers, I'm going to declare, oh, look at this. I'm going to have a text field like an example of a text, example of a single line, multiple lines, some buttons, WX buttons, some log levels, some radio buttons, some check buttons, a lot, like all the sort of controller. And then I'm going to lay them out. So I'm going to now I'm going to create a vertical sizer, start laying out my controllers. And then so let's run this and take a look at what we see here. And so we take a look, and that looks kind of like what I was describing in the code. I've created a couple of controllers. I've laid them out. They more or less the WX widgets library will do all of the underlying lifetime management. It will do all the layout for me. WX widgets is pretty great. Cool. Okay. If you wanted to follow along at home and build some of the examples, that's where you go. Okay. So this is what we were just looking at. So I've got my code over here, and I've got my app over here. And I think where you see is, let's pick apart what we looked at. So if you look at what we see, I've got my controllers, like I said, like the text controllers, and they correspond to the lines of text. And so I think when you look at the code, it's pretty easy to visualize, hey, I want a button on the left, I want a button on the right, I want a radio button, I want a choice one, I want a blank box one. I'll even note that if you'll notice, I want this to be extended all the way to the edge of the screen. That's what I can do by, I've described those. And and it's a little, like I said, this is WX widgets language. It's a little hard to sort of maybe all the details, like why is there a this? Why is there a new? Why is this thing not allocated? Who's holding on to these lifetimes? But WX widgets adds the button to the this. It's sort of a hierarchy of ownership, and they manage all that lifetime management underneath the hood. So I'll say that's a WX widgets paradigm. We're not going to go too much into that. Okay, let's go down and look at that layout section. So this was a second part of the UI code I wrote. The first part was all about creating the controls, and the second part is all about laying out the controls. And so if we were to look at this, we see, okay, I'm going to create a vertical sizer box, and I'm going to add these little text lines. Okay. And then I'm going to lay out a static sizer box, and I'm going to add the checkbox, the less box, the box. And it's like, okay, you can kind of see, you're like, oh, I'm constructing things, I'm laying them out. Cool. Now I'm going to create the sizer box, which is going to be the left hand and the button and the right hand button. Cool. And then finally, what I'm doing is I'm actually creating a larger sizer, and I'm sticking each of those each of those blocks of elements into a vertical sizer. So and this is pretty common when you're building a UI. But I'll say when I look at this, it seems to me that the layout here is pretty fragile. Like, as in, what do I mean by that? Like, let's say I accidentally forgot to add a line or something got mixed up in a merge. And then suddenly, like, that is a very different program. So like what it would do is like, it wouldn't know where to put that button. You'd end up looking like this because the layout part of the program wasn't informed as to where those widgets or those controllers I allocated should live. What if I accidentally copied and pasted the wrong name? I mean, it's not too uncommon for that to happen. Someone like, whoops, I didn't put in sizer details. I put in sizer text. It's like, and I mean, honestly, that is a word salad in there that I can't tell. Like it's hard on the eyes, and you could you'll end up something that looks like this, and that's not maybe what your designer told you it should look like. So these are pretty easy mistakes to make, and you have to kind of be very, very exacting with the way you want to lay it out. What would we say that's different between these two like parts of the code? Anyone, like, why does this one seem to be easier to comprehend maybe than this one? You can talk loud. This is actually a little bit of interaction. Yeah, hey, in the back.
The left one is data and the right one is methods.
Oh, the left one is data. And this is all like methods.
Yes.
Yes, exactly. Like I would say this one feels more like I'm just kind of constructing objects. And this one feels like I'm saying, hey, lay these things out here, one after another. I have to be very exact on what I want to do. And that's really the difference between what I would call declarative programming and imperative programming. From Wikipedia, the source of all knowledge, source of all real knowledge. I'm sure there's going to be AI that's going to make up knowledge.
Not ours.
No. Declarative programming is the non-imperative style. Never good to describe the definition of something as to what it's not, but it's a non-imperative style of programming in which the programs describe their desired results instead of explicitly listing what to do. The way I think of it is imperative programming is how to do something, but declarative programming is what I want. This left-hand side feels much more declarative than the right-hand side. The right-hand side to me feels much more imperative. I'm instructing the computer what to do. So how can we make the layout, the right-hand side, more declarative? And this is what the rest of the talk is really going to be about. And this is also, and I'll say, don't concentrate on the fact that I'm doing this as a UI program. This could be done with any type of programming that you're doing. These are good techniques that you should follow and great ways of thinking about programming in general. Okay, first of all, I'm going to need to do a much simpler program, something I can fit on the slide. So this is going to be the program we're going to play around with. Really quite simple, very toy. I'm going to have 4 controllers. I got dog, right, left, cat. Dogs are going to be a text controller. Cat's just going to be a text. I'm going to lay some stuff out. I've got some sizers to go along with it. And and as we said, okay, I've got my controllers. And then I've got my layout. So let's do some refactoring. The first thing I would do when I encounter any sort of program like this is, well, I'll say I'm an almost always auto guy. I mean, always auto. I'm not sure about the almost. I generally use auto wherever I can. So first of all, let's just kind of like get rid of all the type repetition. The types are the types are clearly on the right-hand side here. They don't need to be on the left-hand side. So auto whenever I possibly can. Cool. So now actually after we do that, we can see these like sort of temporary text objects. They're just like used right away in the program. So I don't think we really need them. So why don't we just stick everything in line? So let's go ahead and like just move everything around and stick it all together. There we go. So like now we've got a little bit more of a compact program. And in fact, actually with this, now we can start seeing some patterns emerge. And so if we look at these lines, I'll note we have something very common. the common piece of functionality I'm doing across all these lines, I have type. I'm doing something across a bunch of different types. And I have a bunch of different value parameters. So the observation I'm having here is I have something that is very common. It has an argument which is its values. It has another argument which is its types. And whenever we think about like arguments, like we think about values as being arguments for functions, but types can be arguments for functions also. We take them as templates. So let's refactor this. Let's refactor this. Okay, there we go. First of all, I'm going to put in a namespace. It's pretty nice to use namespaces. I really encourage you to do that when you're programming. Just puts everything into a place so you can really keep your code separated from everything else. And there's going to be the function I'm going to create. So if we took a look here, like I said, I have my common parts of my functionality, the things that I'm going to do with everything. I have my type parameter. As I said, widgets or templates is how we take in type arguments. And then I have my values. And those are going to be our good old arguments to functions. So let's now apply that refactoring to the code below. And pretty straightforward. Now I just have some functions which are going to take in my parameters, this, and do all the magic for me. This code and that code on the previous slide were basically the same. And cool. Now, if we look at what we have here, I would look at this as saying, hey, I actually have some state and a type. So I have my type. This is a thing on type, and there is some state here. It's like I'm holding on to some state. I have the widget type I want to do something with, and I have some state I'm holding on to. Eventually, I will use at a future point. And when I see state, I think about records or structs or classes. So instead of having a free function here, what if we could make this a type, a struct, and inside of it, let's have it hold on to the string. So it's going to be constructed, it'll hold on to that string, and then it'll have a function that later will add it to a sizer. And this is almost kind of like a factory function at this point. I'm going to create a thing, it's going to have a string in it, and then it'll stamp it out into a sizer when I give it a sizer. So effectively what I'm doing is I'm going to sort of have these like structs that they don't actually do anything, they just hold state. But when given a sizer, they will create and add the widget of its type into it, sort of like a factory function would. And so it would look something more like this, which is I would now have a struct right here on the stack, and I would call create and add on it. And this is actually the same code as on the previous slide too. It's not a free function anymore. It's really kind of weird to kind of like, well, why are you putting things into a struct and then just passing it as an argument? Maybe I'm making an extra copy of a string here, possibly. Maybe there's an optimization opportunity in the future. But I think this is a good way for us to start re-examining our code and seeing what we're trying to do. Sort of take a look at what this code is trying to do in a different way. Okay, so then we'll note one of the things I may have slipped in here is the sizer flag here was slightly different than the other sizer flags. And when you're doing UI and you're dealing with designers who have their opinions about how things should lay out and scale, they may have like, oh, no, we need to expand this one needs to contract, hey, keep these all in proportion. You may have those constraints and requirements. So it is not unusual to have things that are very similar, like almost everything having exactly the same, and then maybe having one odd exception in there. So I think about that as in, maybe what I should do is instead of having this be given as a function argument here, maybe some of these widgets could have specializations. Perhaps they could take in, I don't know, like an optional sizer that says, if this has been passed in, honor the sizer, otherwise use what was constructed later. So this is like a point of customization that you can do, which is someone's like, hey, I want all these to be the same, except this one, make it slightly different. No problem. I can just add that as an additional argument to that widget, and that widget can now be special. Okay. All right, we're gonna go through one more little bit of refactoring, and then we're gonna, well, I'll just actually pause here. Everyone good with me? Okay. Let's take a look at this. Now that I've had the chance to do some of this refactoring, let's observe what we have here and make it a little easier to see. So I'll note I have my sizer, the things I was adding to, and these all generally now look the same. I mean, if there were a lot of them, easier. I have two things, but the structure of what I'm doing here is pretty similar. In fact, actually, I'm applying a function on a set of things. Now, if this was a vector of objects, I'd probably use an algorithm to do it. But this is not, these aren't instances of the same type. They're different types. What do we call a collection of things of different types? Not a variant. It's not a variant, not a collection of things.
Union?
A union is not a collection of things. You can only do one of those things.
Tuple.
Tuple. It's exactly right. This looks like a tuple. It is a collection of things. Like variants are, it can be any number of a set of things, and a union can be any of a set of things, but they can't be multiple things. A tuple is what I would call a heterogeneous collection. A vector or an array would be a homogeneous. It would be a collection. It would be a non-heterogeneous collection. It would be the same because it's a collection of all the same things. So this could be represented as a tuple. I could have a tuple, but now I'm in the challenge, which is I want to call that function on each member of a tuple. Now, it's really easy to think about if I have an array of items and I'm going to want to call the same function on an array of items, I just do a for loop and just walk through the for loop and go boom, 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 boom. How do I do that with a tuple?
Type erasure.
Type erasure? Oh, wait, what was that? Standard apply. Standard apply. Yes. You have done some template meta programming in your time. This is not a common function to use. Like, do not feel like, don't feel bad if you haven't seen this before, and probably actually count your blessings if you haven't seen this before. You're not doing that type of programming. But standard apply is actually a pretty useful function. It's part of, looks like C++17. It is a doozy of a function to wrap your head around. There are many syntactical things in here. There's a lot of ampersands and a lot of autos, and not just auto, decal type auto, which I still don't even know what decal type auto means. I'm like, I always have to look up what decal type auto means. And then even using it, the syntax is a little difficult to understand. You got 3 periods. I mean, you don't just have 1 dot, you have 3 dots you have to use. And so these types of, this type of function is not commonly encountered. And I often, like when I have to use it, I look it up. But so let's attempt to use apply. And first of all, what I'm going to do is I'm going to make a tuple that will hold on to my widgets here. And then what I'm going to do is I'm going to call standard apply on it. And so let me just like sort of see if I can zoom in on this one, because it's just like, let's make this a little bigger and easier to see. So yeah, you can see I have my tuple here. I'm giving my tuple as an argument. It is now being, this is a lambda in here. My lambda it's going to capture this, it's going to capture the sizer, and it's going to take in auto ref tuple argument, which is like, okay, yeah, that's easy to understand. And then we're going to do an expansion here and call every member of the tuple with this create net. I'll say that was not easy for me to code up, because I had to look at it 3 or 4 times. And I'm like, is that right? What's the compiler error look like? The compiler, oh my god. Yeah, these are the areas that you're like, whoa. But once I have this, actually, this is actually pretty powerful. So now I have my, I'll get rid of the text there. So now what I have is my tuple, or so my widgets here, I can now apply them. Okay, great, cool. Okay, well, the flags here, notice how I have the flags in here. Maybe I can pull that out to be an argument to my lambda. Just a little bit of cleanup there and refactoring. Okay, cool. All right. Let's make this a free function. Let's refactor this, get this out of the code where I have it. And so we're going to have a special create and add function. And the create and add function is going to take a tuples and it's just going to call this. So it's really just like a straightforward refactor, and I would invoke it this way, which is so before where I was like, hey, I've got my left and my cat here. I'm just going to create and add with the board with the tuple, and that's going to it's going to take this widget, which is going to be these are going to be structs containing strings, and it's just going to go ahead and create them, pass it this function, and it's going to create and add. It's the same code. It just sort of looks really wildly different, but it basically is doing exactly what it had done before. Taking in a tuple here, it's kind of weird to see the word tuple here. It's like sort of getting in the way. I could get rid of it by creating an overload that takes a parameter pack of any types of widgets. And then I'm just going to go around and I'm like, I'm going to call make tuple on this, so the user doesn't have to see it. And now actually, it makes the code a little bit more simpler. And oh, actually, now we can start seeing it's like, hey, what am I doing? I'm going to create and add these things and add it to that button sizer. Okay, this is starting to feel a lot more like easy to digest. Now, I think it would be kind of cool to use a little bit more modern C++. You'll notice my type here for W is just type name for the template. That's the moral equivalent of void star for your arguments. Probably shouldn't use void star as your arguments in C++. We should give it a nice strong type. How do you give a strong type to your templates in C++? Concepts. Let's write a concept. And I got to use concepts on my slides. I was like, yes, I get to use concepts. But the idea being here is I want to constrain what the type is. And you'll notice I keep using this term create and add. I'm calling create and add on all these tuple arguments. Those widgets are all things that can be you can call create and add on them. You can create one thing and then add them to a sizer. Let's make a create and addable concept. A create and addable concept is anything that conforms to be able to be called a create and add to a window with a sizer and some sizer flags. So let's now add that as a requirement. So now, in theory, if I got it wrong, the compiler warning shouldn't be as bad. I will have to say in practice, that doesn't seem to have to be the case. The promises, we were promised great things, but we didn't quite get the great things.
There's no contract.
There was no contract, and then, oh, I'm sure contracts are going to have their own. Well, that's for later. So, all right. Let's recap as to where we were, because I went through that pretty quickly, but I think they all seemed like very easy steps. And now look at where we've ended up. Before we had controls and layouts. Now it's starting to look a bit more declarative. It's like, hey, actually, I can start seeing the pattern emerge, which is, hey, these were these buttons they laid out. It's like, oh, I'm adding them to the sizer. I'm adding them to the sizer. Yeah, that's starting to look better. But I think we can go further. And so this might get a little, I might lose some people along the way. So if you do get sort of like, throw a flag if you're, I feel like if you feel like I've gotten over to a step too quickly. All right, so what I see here is I'm creating a box sizer, I'm adding something to the box sizer, and then I'm just adding that sizer text to the larger sizer. Sort of like I'm creating a thing and I'm adding a thing and I'm doing, and we had done a refactor as to where I took a bunch of arguments and gave them to a class to then stamp things out to be more like a factory function. I think we can do the same thing again. I think we can take all of this and sort of construct the sizer. and then add that sizer to that top level sizer. So I'm going to, well, they're not very good names, but I'm going to use the term sizer. I'm going to create a class sizer whose job is to hold widgets and then apply them to a sizer. Collect them all together and sort of like as we were laying it out. And that's going to be its job. It's going to take any number of create and addable objects, those widgets. It's going to have an orientation. We saw that there were vertical sizers and horizontal sizers. So let's take those. And when we call create and add, what it's going to do is it's going to create the sizer it needs, sort of like that factory function. It's going to then, given that sizer, go to all of the widgets it has and says, hey, add, create and add, create and add, create and add, and then return that sizer as an argument to whoever called it. And what would that look like? So here's what we had previously. I have my top level sizer. I'm creating a box sizer or horizontal sizer. I'm going through and I'm saying, hey, add each of these to this thing. And then at the top level, add the result to the top level sizer. So with this class that I created, what I'm going to do, I'm going to say, hey, there's a sizer object. I'm going to construct with all these things. Then I'm going to call create and add. And that's going to act like that factory function. It's going to create a sizer. It's going to add each of them, and it's going to just return it. Good. Okay. Now I'll note, I'd love to, like it's really, these seem like two different steps. What if I could just have this one function do those two steps together? Let me consolidate those two together into one sort of larger function. So what it's going to be is, how about I pass in that parent sizer and the parent sizer flags to create and add, and then what create and add is going to do is it's going to go ahead, create its sizer and then add it to the parent sizer. And I'll return it as a sizer, for future use cases. So then now, instead of having this temporary object get created, I just do this. I say, hey, I've got a struct. It's going to contain all these things. When I call create and add on it, it's going to create a sizer, stamp out each of the widgets inside of it, and add it to the sizer I gave it. We have a refactoring opportunity here. I'm giving us, I have to take a sizer argument. I'm giving it a sizer. Might be necessary for as a point of customization, but for the most part, I probably don't need it. I can add that. I can do that optional. I can do the optional flags trick I did before, which is if something doesn't need to have a flag, it will use the parent. If for some reason it needs to have a special flag, it'll use its own. Cool. And so that means I can get rid of that line of code there. It's not needed because it's exactly the same as its parent sizer. Cool. Gosh, I really don't like that horizontal being right here. It feels to me like sizer is going to take this enumeration as an argument. That's a 32-bit number, and there are only two possible values, vertical and horizontal. I guess there could be a z-axis, but even still, the number of bits that are being used to represent orientation is really, really small. And also, you have to think about, like, if this enumeration was some undefined value, I'd have to handle it in the proper way. Like, I didn't check that to make sure it was oriented correctly. It doesn't feel like I need to have that when it's so constrained. So why don't we solve it with type systems? Just let me make specializations, a horizontal sizer and a vertical sizer. Horizontal sizers, they're going to take horizontal, vertical. I'm going to take that away from the user. They're not allowed to choose that. In fact, actually, it allows me to get rid of one more line of code. I like that. So there, now this is nice and tight and compact. I really like the way that looks. So I'll confess, I snuck something into the slides back then. Or at least, I mean, I was like, I think this is kind of sneaky. And it's really kind of a little bit mind-bending to me, but yeah, it works. So I'm not sure if anyone noticed, the sizer has a specific function. The sizer has a create and add function. The sizer, which takes in any number of creates and addsable, itself is create and addable. Sizers can be added to other sizers. And so it's like one of these, oh my God, this is crazy. Well, okay, I think it's crazy. But it is one of these interesting things. Like we have noticed, like, hey, by using create and add, now we have this concept of widgets that can be added to sizers, that can be added to bigger sizers, that can be added to other things that could be create and addable. We can create hierarchical data structures that now get stamped out into UIs that we want. So what we should be able to do is write something like this. So instead of having a vertical sizer and then I have to add, I should be able to just say, I've got a vertical sizer, it contains horizontal sizers. But one of the things I'm missing here, let's take a look. So how would I do that? I'm missing the call to set sizers and fit. This is WX Widget's way of taking a bunch of sizers and a bunch of widgets together and saying, okay, I'm going to calculate all of the bounds and everything like that. That's that last function that needs to get put in there. So I had create and add. This is not the same thing as create and add. This is a very different function. This is sort of like almost like a finalize, almost like attach it to something. So I'm going to use the attaching it to the parent window. And so this will be a special function inside the sizers. So sizers have create and addable, but they can also be attached to a parent window. And so they'll take in whatever orientation they are, whatever the type was specialized for. It will have an optional flags to use. But the very important thing is it's going to call the parent, the argument called parents, set, sizer, and fit. And so this is what it looks like. And I just need to attach it to this, the frame that it was all declared within. And there you go. That is what I would say a much easier to read UI declaration. It's like it declares what it is. I can even see it's like, okay, hey, the sizer, everything's going to expand. Oh, look, this one is special. It's not going to expand the right way. Okay, I can see that. Got dogs, widgets. Oh, it's I like the nice part because it's vertical with a V sizer. If you want it to be fancy, you could put the horizontal ones all on the line and tell client format not to do that to make them sort of horizontal. And we wrote that library, and it's less than 100 lines of code. And most of those lines of code that we wrote are white spaces and sort of just the way client format decided to format things for me. And so, if we take a look at what we started with, this is where we started. And you can kind of see, yeah, I can see the sizers, but this I think is, it's much more compact. I think you can, this requires me to at least roll my eyes horizontally a little bit, I can probably read about 5 or 6 lines at a time. Yeah, I can fit that all in my brain at once. It's much easier to see the intention. I can see that, like, hey, this was meant to be vertical, this is meant to be horizontal. It's really hard to forget one of the things. Yes, granted, I could maybe have forgotten to put the widget in here. And if I had done that, yes, I could do that. But I think it's harder to do something like that because you'd be like, oh, why aren't those widgets all aligned together and they're sort of pockets of horizontal sliders? Adding things to the wrong sizer, accidentally putting this one and that one is greatly reduced. I think it's very, very dry, as in don't repeat yourself, dry. Like I'm not really using a bunch of words over and over again. I'm really like expand. Like just use it once and then it's implied to be of everything in the hierarchy, probably the way we would think about it naturally anyways. And that's just the beginning of sort of the work. So here was our original example that we started with, a whole bundle of text. With some refactoring, some additional techniques, it can be reduced to this. And I think that this is much more readable. So, just about almost 8. Observing your program, sections of code that are imperative. Like, do that. Like, look at the code and saying, like, oh, I'm saying do this, I'm doing this, I'm doing this. And then think about it. Could these be done more declaratively? Could I say, instead of saying less about how to do something, instead of saying, hey, for each of these objects, calculate this value and add it to this result, just accumulate them. Just transform them into different values and then add them all up. Algorithms are incredibly declarative, and you should probably be using them. You don't. I think especially with the advent of AI, you probably need to spend less time telling the computer what to do and start telling the computer what you want. Refactor your code. I think it's actually, I actually have a lot of fun refactoring code. I'll like, someone has a bunch of code that's like 50 lines long or 70 lines or 100 lines, and I'm like, oh boy, yeah, let's do this. I'm gonna break yours functions into a bunch of free functions, and oh my God, actually you've got 4 other things that are just like all the same function. Wow, that was pretty interesting to see. Know your types. Know your algorithms. All of what's happening in C++. A lot of good stuff happening. And that's my talk. Thank you.
All right, good stuff. So yeah, we got some time for some Q&A. So does anybody have any questions?
As long as I put on the slides. Oh wait, is there someone asking questions online? Oh no. Nicholas.
Yeah, so now that you're at Facebook, have you thought about upstreaming any of this code to WX widgets?
I mean, I don't know if anyone would use it. I mean, there's like, I guess the good people over at, who writes in WX widgets? Oh, Audacity uses it. I think we were talking about who uses it. Yeah, I mean, sure, I guess. I'll ask the powers that be.
Right, because I think you've got a lot of very powerful ideas here that, I mean, the WX widgets people were programming in probably 96 when they started or something.
Yeah.
Like that, you know, and they didn't have the tools you currently have, right?
I have thought about like how to put this out there. I feel like it's one of these, I'm not sure the library's quite ready yet. I have a WX widgets library. If you find it on my GitHub, there's WX UI. And it's, no. Actually, I'll say, my intent, I've actually seen this with a number of projects, is I'm pretty much okay with kind of keeping existing code as is. I look at ways I can take existing projects and make them better. Like sort of, if you, there's a C++ version of FFTW, which is really just a wrapper on FFTW to make it usable in a C++ context.
Yeah.
I look at it that way. I think of this as a library that makes WX widgets more declarative. You can still use WX widgets, and in that way you can use this. I actually see a similarity with Swift UI and Cocoa, because Swift UI, maybe a lot of this was inspired by Swift UI, but as a declarative UI, you can do a lot of things. But once in a while, you're like, "Ooh, I really need to do something like gross," and you'll reach underneath the hood to grab something. So I don't see this as something that is there to change WX widgets. I see this as something that can make someone who's comfortable with WX widgets be more comfortable with programming in this way.
I see.
Yeah.
I have a question. Okay. So I think you said a few minutes ago that you didn't think the language was ready? As in, did you mean C++?
Oh, no. I didn't think my library is ready.
Oh, your library is ready. Okay.
Yeah, so if you're on GitHub and you find my repository, the WX widgets is there. I've been playing around with it. I'm using it in my own project. I think I'm missing just a couple of in fact, actually the next slide, part 2, there will be a part 2, will be one of the things that I find after doing this refactoring, I was like, oh, I can actually do binds and like, hey, if I click a button, I want it to call a function. And that's pretty interesting. But then now I'm thinking about if I have a large UI that I want to lay out, I want for loops. I want filters. I want to give in a bunch of types, filter out the types that don't make sense in this UI context. I don't think the library is quite robust against copying those structures. I'd like to almost have like pockets of the UI that you can like sort of stamp out, but that means I think some of the lifetime stuff is just a little not ready for prime time. But that's what I mean by,
That makes sense.
yeah, my library's not ready.
Yeah, so then I'll ask a
Yeah.
real question then. So my real question would be, so you mentioned that something that's important in these like high level UI libraries is being able to sometimes like reach down into the guts to like do something that's not easy. Do you think your library makes it easy to like reach those like underlying things, or are they hidden behind all these types? Like, is it hard to reach those?
I have found it's that sort of line of like, this should be a class because I want to protect the internal objects. And then I was
Yeah.
like, I really need to get that underlying like instance of the widget. And I'm like,
Yeah.
okay, I'll make it a struct. There are certain things I'm like, oh, you should never make things struct if you have any sort of not constraints, invariants. Thank you. Yes. And so sometimes I have these invariants and I'm like, this is not appropriate for it to be a class, a struct, but it's just to the point where I'm like, I just need to get that one.
Yeah,
I have to figure out better ways of doing it.
got it. All right, do we have?
Alice.
I don't understand the comment, you should use a class if you have invariants. Could you expand on that?
I think what it is if I have assumptions about how the internal records, the internal members should be kept coherent, by having those exposed, I can't control that. If there's an invariant that like a number or an enumeration has to match with the size of a string and they're just freely accessible to be written, I can't really control that. And so that's where that's a general rule of thumb for me. I think, I can't remember you said it too. It's like that if something about your lifetime or something about the way that all of the structured members should work together, you can enforce those at function call points.
Have you thought about like, just a question, if you had to define like tap order, how is that gonna play? I think you briefly touched about like having access to underlying structures, but if you had to define like tap order as you tap through the fields and like not use the mouse, for example. I mean, I know that's like a forgotten concept, but
Yeah.
I find all the new UI is ridiculously clunky nowadays.
Yeah, actually, I had thought about set focus, but not the order. And you're right. Yeah, I think some of these frameworks use the construction hierarchy to probably dictate the tab order. And because of that, suddenly if I make assumptions about the way I construct things on behalf of the user, you get there. Like, I think of it though, I didn't maybe remark on it, I could have, is it's really like I've created this thing that is like, you create this data structure that's all just sort of passively sitting there. And then there's this engine that you apply it to, and it just kind of like runs through all this stuff and starts creating them. And so it's like, it's almost like that attached to function is like your engine. It's the thing that just runs the rest of this sort of declared program that you had. And I think sometimes UIs make assumptions about the order in which you create things as being the tab order. And so I wonder if I have to think about this one. Thank you.
If I'm not mistaken, in Windows, you pass in the number, like, that's been super long time I've done that, but I don't know if
Maybe there's a way to do that.
Linux and Mac use the same concept,
yeah,
but
yeah, yeah.
I mean, it's interesting in a way that how you nest them visually is one concept, and you have that totally parallel concept like what the order should be, and you want to merge those. So it's
Yeah.
more of a philosophical question. I just wonder if you kind of thought about it.
I hadn't thought about it.
All right, we got time for one more. Better be a good one.
Yeah, you mentioned you thought about the set focus. How do you do that with this? Because there are no names of things here. Everything is anonymous.
Come see my second part of the talk.
I heard that before.
I promise this time.
Now be honest. The reason we are still waiting for the part 2 is it's still compiling, isn't it?
It's Okay, I think that's great. That's a great way to end it. Come back to part 2.
All right.
Yeah.